Alright guys, so your group has been assigned kind of the first type of chemical reaction that we're going to cover, and that is synthesis reaction. And so just the word, synthesis in and of itself kind of has the idea of things, coming together to form something new. And as you've already kind of been introduced to, that's exactly what happens in a synthesis reaction, is we take kind of two simple reactants and we bring them together to form one product. Okay, so two simple reactants coming together to form one product. And that's kind of what we have in the illustration here to the right. So we have A and B, and they come together to form this new compound, AB. Okay, and so we've got a few kind of examples here for you. So in this case, we have silver combining with oxygen to form silver oxide. Okay, so again, it's a synthesis reaction. And then the second reaction, we've got hydrogen coming together with oxygen to form water. Okay. So one thing that's, kind of important to point out that'll be helpful to you is some of the elements that we're going to encounter are what are known as diatomic elements. And that means that anytime you have just that element by itself, they come in pairs of two. So for example, I'll kind of show you a picture here. So here are kind of our diatomic elements. So you've got hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Okay, and so there are 7 of them, and they kind of form the number 7 kind of on the periodic table with hydrogen kind of over here. But these are elements, again, that always kind of have a buddy with them. And so as we're writing them kind of through the rest of this video, if you see me write, Br2, then I'm just accounting for the fact that bromine is a diatomic molecule. Okay? And so some other elements that aren't quite diatomic, but that also come in groups of more than one, are going to be phosphorus, which we encounter as P4, kind of a little tetrahedron it makes. And then sulfur, which is S8, and that kind of forms a little crown-like shape, often known as crown kind of sulfur. Okay, so that's just something to be aware of kind of as we're going through, but this is something we'll address more in class when we cover balancing reactions. Alright, so back at it. Okay, so what your goal is that you want to be able to teach your classmates how to not only identify, but also how to correctly write the products for a synthesis reaction. Alright, so I'm going to walk you through kind of 3 examples to try to help you learn this skill so that way you can teach it to them. Alright, so the first example that we're going to do is we're going to combine hydrogen, and since hydrogen is one of our diatomics, when I write hydrogen, I'll be writing H2. So this is hydrogen. Okay, and then to it, I'm going to be adding sulfur. Now, sulfur, again, if we look back at our picture here, is also one that's a little, different. So we're going to start out as S8. That's just when we have sulfur by itself. Okay, and so now it's up to us to kind of predict what the products of this synthesis reaction will be. Now, the way we can tell that it's synthesis is we've got 2 simple elements coming together, and so we know that we need to bring them together into one product. Okay? Now, I'll tell you kind of straight up what it's tempting for most students to do. So most students will simply look at H2 and say, okay, I know in my product I'm going to have 2 hydrogens and then 8 sulfurs. And so they tend to want to just copy over whatever's on the left hand to the right. But kind of where the issue lies with this is that whatever product we have needs to be a balanced chemical compound. And so what you have to get them to do is kind of come over to the side and piece together your compound so that it balances before plugging it back into the equation. So here's what that looks like. So I know I'm dealing with hydrogen, and I've got to combine it with sulfur. Okay, so now I just want to consider the elements kind of by themselves and their charges. So just hydrogen by itself takes on a +1 charge, while sulfur takes on a -2 charge. And so I'm, kind of using this from your charge sheet. So this kind of takes us back to what we did with ionic compounds, where we want to put our elements together so that they combine to balance out the charges. So if my sulfur is a 2-, I'm going to need 2 of my positive hydrogens to balance it out. So as my balance formula, my product should be H2S. Okay? And so then, once you find your balanced product, then this is what you'll go and plug in. So my new product should be H2S. Alright? And this is an acid, so if I wanted to go ahead and name it, there's no oxygen, so this would just be hydrosulfuric acid. Okay? And so then after you finish writing a product is when we need to go back and balance our equation to make sure that the number of the elements in our reactants balances out with the products. Okay? So for example, I've got 2 hydrogens on my reactant side, 2 on the product, so that looks good. But if I take a look at my sulfurs, I've got 8 sulfurs on the left and only 1 on the right. So again, like we learned in class, when balancing a reaction, you want to balance by changing the coefficient, which is the number out in front, not the subscript. Okay? So now, I've got my sulfurs balanced, but in doing so, I kind of unbalanced my hydrogen because I now have 16 on the right, and so I need 16 on the left. So I'll go back and add an 8 there. So this would be kind of my overall finished reaction that's balanced and has a complete, product. Okay? So now we're going to go ahead and do our last 2 examples. Alright. So now what we're going to do is we're going to take calcium and we're going to combine it with bromine. Okay, so calcium, it's not a diatomic element, so we're just going to write Ca. But if we think back to our chart, bromine is one of our diatomics, so we're going to have to write in Br2 for bromine. Okay, so we've got our 2 reactants. So we can tell it's synthesis again because you've got 2 kind of simple elements coming together. So we need to use them to form one product. So again, what we have to do is kind of come over to the side, make a balanced chemical compound, then plug it back in as our product. So we'll take our calcium, and its charge is 2+, and we'll take bromine, and bromine's charge is 1-. Okay? So now what we want to think about is to get our charges to balance, we're going to need 2 bromines. Okay? So my balanced formula will be CaBr2. Okay? So then we're going to take our formula and plug it back in to our equation as our product. So our formula will be CaBr2. And so if we write the name of that, just using our naming rules, that's just our calcium bromide. Okay? And so then at the end is when you go back and balance the equation overall. So I've got 1 calcium on the left, 1 on the right. That's good. 2 bromines on the left, 2 on the right. So in this case, it happens to be already balanced. Okay, so I'll just write that in. Alright, so one last example for you guys. Alright, so this time I'm going to take aluminum and I'm going to combine it with oxygen. Okay, so aluminum is just Al, it's not a diatomic. Oxygen is a diatomic element, so I'll need to write O2. So then again, I come over to the side and I form my balanced product. So again, what it's going to be tempting for your classmates to do is just to copy over exactly what they see. That's not the case because it won't always get you your balanced product. So bring your elements to the side. So we've got aluminum, that's 3 plus, and oxygen, that's 2 minus. Okay. And so now I've got to put them together so the charge is balanced. So I know that 2 can't go into 3 evenly, so I find kind of the least common multiple of 6. So it should end up taking me kind of 2 of my aluminums and 3 of my oxygens to get everything to balance. Okay, and that's because my positive 3 times 2 gets me to plus 6, and my negative 2 times 3 gets me to minus 6. So that lets all my charges balance. Okay, so now I'm going to go back and plug this in as my product, Al2O3, and now I can just name it aluminum oxide. Okay, and then at the very end I go back and balance my equation overall. So I've got 2 aluminums on the right, so I need 2 on the left, and now I've got 3 oxygens on the right and only 2 on the left. So it looks like, again, I'm going to have to try to go for 6, which is the lowest number they both have in common. So if I add a 2 here, I've got 6 oxygens on the right, and if I add a 3 on the left, I've now got 6 on the left. But because I added the 2 on the right, it kind of changes my aluminum to 4. So now I have to go back and add a 4 to make sure everything is balanced. Okay, and so now I'm good to go. Alright, so there you have it. There's kind of your basic rundown of synthesis reactions. Thanks for watching.